yet. I'll open up when the speaker speaks you in. They should do it soon. I think we're running late.
Okay. Good afternoon. Are we all set and done? So welcome. Thank you for staying around for my session. It's already getting later in the conference. It's always a hard thing. So my name is René van Osnabrugge. I work at Xspirit as a DevOps transformation consultant. So I do a lot of things on DevOps, Azure, continuous delivery, all that stuff. And one of my biggest concerns of today is that I have the developer background. So I'm not an IT pro. I think it was the Azure bit of my title that actually brought me in this conference here. So, but I think I have some interesting things to tell you. And I have another concern as well. So I am actually a bit nervous here because I saw the interaction of the Finnish people with the audience. And one of my first things is interaction with the Finnish people. So that is something that I can actually be a little bit nervous about. So who here concerns himself as a developer? Who sees himself as a developer? I saw it yesterday. Oh, it's more than yesterday. So all these skills in one day, that's good. And who likes to do all kinds of manual, repetitive tasks? And who likes to automate that with a bit of a scripting or some automation, with even if you are more an IT professional? So okay, so we are all engineers, like. So then we are at the right stage. And then I have another thing that I would like to do with you together, and that is counting. Can we do that in Finland? Counting from 1 to 5, so 1, 2, 3, 4, 5. So I count down from 3 to 1, and then we count to 5, like slowly. 3, 2, 1. 1, 2, 3, 4, 5. Beautiful. So, great. I had a backup plan, but okay, so we can skip this one. That 5 seconds, I really wanted you to experience those 5 seconds, because 5 seconds is all it takes if you have a 99.9% availability. That's the amount of time you can be down within an hour. Actually, it's 3.6 seconds. So that's not that much. So if you counted those 5 seconds, you already lost your customer there. You already had to pay some money if that was your SLA. And for me, that percentage doesn't say much. But for me, it opened up when I saw this graph in the Azure handbook that showed me all these figures. So the 99.9% translated into a, 3.6 seconds downtime in an hour. And if you add a 9, it's only 0.36 seconds in an hour. So if you imagine that if you deploy a web application into Azure without doing any fancy stuff, so like a plain vanilla continuous delivery pipeline that deploys your web application, it goes down for about 10 seconds because your sessions are resetted, your configuration pools are resetted and recycled. You have to do a little bit of startup time again, so you're down. So that's where your SLA ends. So product owners and business people that are shouting, like, we need 24/7 availability. Who knows these people? Do we have these people in your organizations? Yeah, I do. Those people do not probably know this graph, and that they also do not actually know how hard it is to keep this availability high. So what I did is that I just took a look at what do we see in the industry. So for example, Azure DevOps also has this 99.9%. Azure Functions even has a higher one, 99.95%. Azure AD, 99.9%. So when you know these downtime figures, this is actually very, very impressive. You can only be down for 8 hours a year. And what also is to be learned of these things is that, for example, Azure Policy that Sjoukje talked about yesterday, at least when I looked it up on the internet, they don't have an SLA. So they don't guarantee you anything, which is probably fine because it normally works. But if it doesn't, and you rely on it in your business, you might be screwed. But there is a good reason for that, and we will come to that later. And yeah, same goes for Outlook.com or ING Banking, which is a banking app in the Netherlands. I use that multiple times a day. Everybody that has the ING as their bank uses that multiple times a day. They don't have an SLA. And I will show you, hopefully, in this presentation, why considering that SLA, considering those numbers that you communicate to your customers is actually a very good thing to do, because it opens up flexibility. But these numbers, these availability figures, this is the way that the traditional ops versus dev gap exists of. Because if you are working in operations, and I believe that most of you here in this room work in operations, probably the availability figures, keeping the systems up and running for your customers or internal customers, that's the KPI. If you don't meet the KPI, customers are unhappy, boss is unhappy, bonus is unhappy. So that's where it goes. Well, ops, they don't want the system to go down. And well, if your bonus depends on it, I truly understand why that is. But on the other hand, developers have another KPI. Developers have the KPI of delivering business features as fast as possible. Delivering. So they have a different KPI. And that's where the gap exists. But we never hear ops people saying, we don't want change because our bonus depends on it. And we never hear developers saying, we want to deliver because our bonus depends on it. It's always sugar-coated. So what I hear from ops is, we need to do launch reviews, change architecture boards, checklists, we need to pre-validate, we need to run first, all kinds of measurements to mitigate the risk of going down. And on the other flip side, what we hear from dev, it's not a real release, it's only a feature flip, toggle, or flag. This is just a hotfix, we need to push this out. It's a UI change, it's only a style sheet thingy, so no worries, we can do it. Or only 20% of the customers face this new feature. So there is all kinds of sugarcoating around this ops versus dev gap, but it doesn't really change. The KPI is still a conflicting thing, and we actually need to solve this one. And I actually forgot to put on my timer, but okay. So conflicting KPIs within an organization, no matter what you do, is a bad thing. And DevOps was around to solve that. And actually, about 10 or 12 years ago already, DevOps started to come to life with all kinds of people that are starting to work together, saw the conflicting KPIs things, and they said, okay, we need to move those things closer together. We need to move the developers and the IT operations people, we need to move them to the same team. We need to introduce all kinds of automation and cultural things to actually solve that problem. But the nice part is that at around the same time, about maybe also 12, 13 years ago, Google also was busy, was working on a similar thing, SRE, Site Reliability Engineering. And those things like more or less grew up at the same time. So if we take a look at what DevOps is, who knows this definition of Donovan Brown? Are we all familiar with this one? Yeah, because it's a Microsoft definition. So DevOps is the union of people, process, and products, or tools, or technology, sometimes you hear that as well, to enable continuous delivery of value to the end users. So what does this actually mean? So people, of course, the cultural part, people need to have a specific mindset, to work together, to have the same KPI, to have the same purpose. Process, the way of work, and products, technology. What tools do we use? Automation, everything around that. And then the most important part, enabling continuous delivery of value. That's what it's all about. All these fancy automation things, it's not the goal, it's not the purpose. The goal is delivering value. And the means to an end is maybe automation and all the things. So that is DevOps. And around the same time, in Google, this guy here, Benjamin Traynor-Sloss, he coined the term site reliability engineering. Because back then, Google was growing their cloud business, they were scaling up. And what he found out, because he was leading the operations part of the Google Cloud, he saw, well, this is not going to work. The way that we operate our systems, like the traditional way of operating system, does not work in our cloud business. We cannot do all these things that we do manually when we run 100,000 servers and scale up constantly and introduce new services all the time and have to be competitive against the market, and we are going to release constantly new features. So he was responsible for designing a new way of operations. So he phrased it like, when you ask a bunch of engineers to design a new operations teams, SRE comes out of it. So site reliability engineering is something that actually was created at Google. And why do we hear about it now? Because Google kept it for its own for a very long time. Only since a few years they said, okay, we are going to open up our practices. They wrote the SRE handbook, the SRE workbook that comes with it, and they documented all their good practices so that it is now available for us to learn from. And we see it already in bigger organizations that are introducing an SRE capability. So to make it a little bit more tangible, I also have found this definition, and site reliability engineering. So it's an engineering discipline. So what I started with, asking who found himself a developer, not too much hands, but everyone in this room, I believe, has this mindset of improving, has this mindset of automating stuff, has this mindset of not liking to do all kinds of manual tasks, opening a ticket, doing some manual actions, closing the ticket and moving on. So we all have the engineering mindset to actually solve things. And that's an important feature of a site reliability engineer as well. Then it's about sustainability. So it's devoted to helping an organization sustainably achieve the appropriate level. So sustainably, well, it's nice if you can do it with 1 or 2 servers, but it's better if you can do it with 100 or 200 or 20,000 servers. So you need to make sure that you can actually handle the skill there. And then there is appropriate and reliability. And we will come back to that later, but the appropriate is really about that 99.9% or that 99.9999%. Whatever you need. If you have a Christmas card application in your company that sends a Christmas card every year to all your employees, you probably don't need a 99.9% availability on that. Unfortunately, what I see is that in the companies that I work for, especially the company that I work for right now, has a SLA that goes for the complete IT department. So that is the SLA to the business. It's 95%. Everything that comes in has that 95% availability, which makes them a little bit inflexible, because some applications need 99.999% because it's business critical, but some, they don't need all that bothering of keeping them alive because it's not really necessary. So appropriate is a very important term to remember here. And then it's about reliability. So reliability, we'll come back to that later, but that goes to, well, how reliable is my application? How reliable is my system? So DevOps and SRE are not two separate things. It's also not the case that SRE is an evolution of DevOps, but it's more an implementation. And well, with the developer background, it's more phrased like the class SRE implements DevOps. SRE is a more concrete implementation of practices than DevOps. DevOps is more abstract, like you need to have automation, where SRE more maybe says you need to do this kind of automation. You understand what I'm saying? Makes sense? Cool. So I'm not going through this whole slide. We can maybe do that later. But if you see the 5 pillars of DevOps, with the organizational silos, accept failure as normal, implement gradual change, you see that the SRE implementation of that is a concrete one. So for the accept failure as normal, they have SLOs and blameless learning reviews in place to actually capture that thing. And we will talk about that. To summarize SRE and DevOps, SRE, so site reliability engineers, so the people, they focus on the reliability of your site. So they build reliability features They build reliability features in the software, in the same code base as the developer teams, but they also build reliability features in the underlying hardware or infrastructure, whatever you need to run that specific application. While the product team focuses on the business value. So what is DevOps? Is it still two separate teams? Maybe. Maybe there is a team with site reliability engineers that are offering their services to multiple product teams, but sometimes the SREs are just embedded in the product team. It is, well, depending on the organization and the organizational sizes. But the site reliability engineers have a different perspective. They focus on the reliability part, where the product team focuses on the business value part. And they work closely together. They share the ownership of the application. It's not that if the product team is finished with his first version of the application, they throw it over the wall and say, okay, you go and run my application in production and make sure it doesn't break. Bye-bye, I see you later. They share ownership. And, of course, they are all engineers. That's why it's called engineering. So the price of greatness is responsibility. This is the major difference, I think, between the traditional development teams and operations team. They share the ownership. So it's not a new way of doing operations. Same thing. Make sense so far? Good to follow? Yeah? Okay. So I think one of the major things that is in place within the SRE practices that you have at hand to actually make sure this responsibility is actually followed is what we see, what I said as SLL star, or SLIs, SLOs, and SLAs. So let's first start with the SLI. It's the service level indicator. So a service level indicator are ratios. So you can phrase something very clearly as the number of successful HTTP calls, for example, or the number of successful operations that completed in less than 10 milliseconds. And so you can really define very, very simple phrases on this is what I want to measure. And this is where also product owners, business people, and developers and operations come together to actually phrase this. What is the appropriate level of reliability? What do we actually need from our application? What do our customers expect from us? So if you have defined those service level indicators, which is a ratio, so it's always a percentage, you also need to make sure that you define very strictly where you're going to measure that service level indicator. Because it would be very strange that if I say, well, we had 80% of our calls successful, and someone else says, no, I measured 95%. But yeah, I measured on the web server. Oh, but I measured on the load balancer, and someone else measured on the client, and the HTTP request didn't even come to the web server because they were broken off somewhere else. So it is very important to actually phrase that as measured at the load balancer or as measured at the client, so that there is no way to actually argue about the validity of the number that you get back. So once you have defined those service level indicators, you can make something that's called a service level objective. And a service level objective is, maybe sometimes people call this an SLA, but this is really the objective. What do we want? So we have the thing, HTTP requests, and we have the proportion. We want to have 90% of our HTTP requests successful. And, of course, over this period of time. Because if I take an hour, then I can only be down for 5 seconds. That's what we saw in the beginning. But if I take 30 days, then I have 8 hours and I can spread it out. I can have 8 hours of downtime at one moment, or I can have 10 minutes a day. So that is really important that you have that time constraint as well. So if you then look at the recipe of that service level objective, you can have 90% of HTTP requests measured at the load balancer succeeded in the last 30-day window. If you create these kinds of statements, that is really the agreement between the product team or the business and the site reliability engineers. We all know what is expected from us. We all share the ownership to keep that keep that level high enough. So if you then put this in place on the timeline and we look at a service level agreement, then we have uptime and we have a service level agreement that we agree with the customer. That's the commercial representation of our service level objectives. Maybe you have more. So maybe we say to the customer, we guarantee you 80% uptime, 80% availability of our systems. But internally, we can have a different thing. We can have multiple SLOs. So we put that usually a little bit higher. So maybe we make it 90% or 95%. Because that gives us room to actually improve our practices and not directly have to credit the customer or give them money back or whatever legal stuff that is happening with not getting to your SLA. So the SLOs are that. The beautiful part, and that is, I think, very crucial in this SRE practice and the shared ownership of your application, is that threshold that you have left over is your error budget. Because if we have an agreement that we have an 80% or 90% SLO, that means that other percent, so like let's say 80%, we have 20% of room to experiment, to do stuff. Because we did not agree to be 100% up, we agreed to be 80% up. So instead of like always targeting for the highest availability possible, we target for that threshold. Because that threshold, that error budget, we can use to experiment, to release new features, to do new deployments, to create new infrastructure, to do all kinds of stuff, because that is what we agreed on with business and Azure. So the other side of the story is that the error budget is the agreement. So we can also say, well, you have consumed all your error budget. We have found that not 80% of the HTTP requests, but only 60% of the HTTP request is successful. So we are not going to release any new features again. We are now purely focusing on the reliability side of things. And once we have fixed that, and the error budget is, well, within the threshold again, we are going to move on to the next thing. So if you have these kinds of agreements, you can also just say, the SRE, they don't care. As long as you keep within your error budget, why would anybody care of how often you release, what do you put in production, do you do your A/B testing, whatever. If it's in the error budget, go ahead, do whatever you like. But if it's not, then we are doing other things. Then we are going to work together, the product team and the site reliability engineers, to make the reliability of the site higher. Make sense? Cool. So what I've done is I created this very small demo in Azure to actually show you what can be done with these SLAs and SLOs. So I have this Parts Unlimited web application, and well, you can just browse through this and, well, buy products, because that is the business value of this application. People want to buy products. And to make it a little bit more interesting to watch, I've also created a load test that is currently maybe running, or it's just finished, but before that I started this presentation. So one of the things that I did is that in the Parts Unlimited application is application insights, so that gathers a lot of metrics of my application for me. So you can see that I have quite a number of failed requests, and well, we are maybe already familiar with application insights. The nice part about application insights is that on the back end, it moves all the data to log analytics. We already saw a bit of a demos for log analytics, but we can see a lot of application-related data here as well. So we can see page views, we can see exceptions, we can see performance counters. We can all that data is automatically gathered by Azure and pushed to the log analytics. So when I, for example, say, now I have already written it. So this is my HTTP requests. So this is my query, requests, where the timestamp is, everything from 2 days ago until now. And I have created this custom dimensions like succeed and failed and a total. So the SLI that we talked about, is this readable in the back? Yeah? So the SLI that I talked about is the number of succeeded requests divided by the total. And that gives us that ratio. And then I'm projecting that and making a nice graph out of that. But if I add something like, okay, I'm going to add my service level objective of 99%. And then, well, we are going to move this one. Then it's quite, it's not rocket science, but it gives you a very nice overview of my error budget. You can directly see what my error budget is at this point in time. I have a lot of room to experiment here, but here we are down. This is not good. So we need to do something about that, and that is the moment we are going to focus more on reliability. Log analytics is very nice to create these kinds of graphs. And what I will show you in the later demo, you can also create alerts on this one. So now it is purely visual, you have to look at it. That's not something that we typically want, constantly looking at a dashboard. But you can have thresholds and alerts on these graphs as well. And then you can actually make them a little bit more actionable. So, back to this one. Are we good so far? Yeah? Okay. So what does down actually mean? Because, well, that's the title of my presentation, when down is not good enough. But what is it when we talk about down? In my previous examples, I constantly talked about availability. But availability is only one of the dimensions that we can talk about. So first of all, it is about the customer. It's not about the software component. So it's nice to measure CPU time and memory and all that stuff, but it's only important when the customer suffers. So if your application is down, that is more, yeah, that's obvious. But if your application is slow, for example, latency, when your application takes 5 seconds to respond, your application is not down. All your lights are still green if you measure availability. But probably customers are going to drop off because they don't want a slow application. They want a fast application. Slow is the kneel down. So latency can also mean down. Throughput can also mean down. Can you handle a number of records? I've tested with 10,000. What happens if a customer comes up with 100,000 records? Do they all process correctly, for example? Can we handle that? And of course, correctness of the data. So we can surface data, but if we do a random query in Google, if I type in reliability and I get results of a pop star, that's not what I'm looking for. But probably in my metrics, I don't see that. Everything is still green. So that's the observability part that you have to consider when building your application. Do I have enough data stored in my log analytics or whatever I use to store that data? Do I have enough data to see what is actually wrong with my application? So correctness and also freshness. So freshness is caching, for example. In some application, it doesn't matter if the data you're looking at is an hour old. But if I look at the exchange rates of my stocks, then it might be interesting to have a fresh view of the data and not an hour-old view of the data, because it can have a lot of impact. So down is really something that you need to look at it from a perspective of the customer. When is it down for the customer? So what does an SRE do? So if you are moving to a site reliability engineering role, what is expected from you? And well, these numbers come from that specific handbook. So this is what Google does. So it doesn't necessarily mean that this is what you need to do. It's no hard rates or limits, but it is a good start. So Google says, well, we have 50% of operational work and we have 50% of project work. So let's start with the project work. So project work is working with the product teams to build reliability features, to make sure that the application is resilient, that it can go up, that it doesn't have downtime when you deploy a new feature. All these kinds of things, circuit breakers. So really engineering practice, sometimes really hardcore development even, but focused on the reliability part of your application. Also, it is about reducing future toil. And toil is something that I will talk about in the next slide. It's manual repetitive work. So because we are engineers, we don't want that. We are going to optimize our way of work. We are going to learn, and we are going to make sure it happens again. On the other side is 50% operational works. It's just the work, well, that we are maybe used to see in this space. Is incidents, tickets, operational work, sometimes manual tasks to keep everything up and running. So what happens when there is a lot of operational work because the application is crappy? Constant incidents. So you have 80% or 90% of operational work. Traditionally, what I see happening is that, well, the operations team has a bad time. They just have more work. When you are doing SRE within your organization, all that work after the 50% or whatever threshold you agree on moves to the product team. They are going to fix their own shit. It's up to them. We have a shared responsibility. We do this and you do that. If you build a crappy application, it's up to you to make sure it runs again. You build it, you run it. So that is an important feature. So back to the toil. So that is one of the project tasks. So when a site reliability engineer, when he is not fixing tickets and doing operational work, he's probably busy with toil. So this toil is manual, repetitive. It's automatable. Some things are not automatable, so then it's not toil. Reading your email or reading through some things is also not toil. It's just overhead. Everybody has that. But it's tasks that can be constantly coming back. And important, they are devoid of enduring value. So it's not adding value. If you have to reboot a server 2 times a day because the memory is full, yeah, you have to reboot it because otherwise it goes down, but it doesn't add value. If you reboot a server, nothing is added there. So you need to move away from toil. And then there's always the question, when is it toil and when should I automate this one? Well, that's really a subjective thing. Probably if you do a thing once a month and it takes you 10 minutes, it's still toil, but it's probably not worth automating it if it takes you a week to automate it. If you do it 4 or 5 times a day, it takes you 10 minutes, then maybe you should start a project to actually automate that stuff. And, well, there are all kinds of things that you can do. You can write measurements and Excel sheets, but you can also just ask people, how much time do you spend on certain tasks? And people really, really know very well what is something that should be automated in this sense. So, what I've done, to just give you a little bit of an example of what can you think of, is that, for example, rebooting that VM or starting a VM. Got a ticket, memory is full, can you please reboot this VM for me? We don't have self-service in place, so people are filing a ticket to actually do that. I think I already said it, I think self-service is one of the major things an SRE can start doing. When the product team do not have the rights or maybe the tools to actually do the work on the infrastructure or hardware layer, you need to give them the tools. And that doesn't mean give them the keys to the kingdom, but enabling them by, for example, self-service. So what I've done is I've created this this bot. So I'm not going to go through the code, but this is an example that you can get from the internet. And this is just a conversational flow. It's a bot that you can use. And if you go to this page dev.botframework.com, yeah, on the totally on the bottom, there is all kinds of documentation, design guidelines, build guidelines, and also starting samples, which what I will show you is just more or less an out-of-the-box sample with some modification for Azure. And it's not really hard to actually get started with this. The beauty of this bot thing is that once you have deployed this to Azure, you can already test it in Azure. That is nice. You can have a conversation, so I can just say hi, and probably it will say something back. It will ask me for the team name. So okay, so that is Polarconf. It's a very stupid bot because he can only ask for VM. So I can say, oh well, which VM name, and then I can have a VM name. So this is interacting with the Azure API, gives me some data back, and I can just move in some commands. So it's not different as adding an interface, but you don't need to have designer skills. This is nice, but what is even more nice is that if you look at this bot, you can also integrate this with the popular channels. So like Skype, Slack, Teams, Cortana, I think that one is now deprecated, or other things. So what I've done here is I added this bot to Slack. So as you can see, I have this SRE self-service RVO bot, and I can have the same conversation here as well. So it doesn't really matter what I put in here, but this one is important. So the VM chat is a virtual machine that I have running on Azure. It's called VM chat. And what I built is I just need the name of the virtual machine, and I will scan all the resource groups for this specific VM name. If it finds more, then it will just ask me, okay, I have already found one. Can you specify a little bit? And then I get an option of what do you want to do? Do you want to start, do you want to restart, or do you want to shut down? I've already started it, so let me just shut down. I will type it in, and now my VM will shut down. This means that I don't have to do this. It's just a bot. People can have this in their Slack channel, and they can do it. If they want to reboot their machine, they can reboot their machine. It's all self-service. So the toil that I have is now actually automated. So your VM is now shut down, and then, well, proof to the pudding, VM chat. This is my virtual machine. Yeah, so it's probably, oh yeah, okay, it's stopped. I didn't show you before, but trust me, I'm Dutch. It was started. Ah, okay. Actually, it was not started. It was just, I'm just playing with you. No. I spent actually a lot of time in this bot. I should have shown it before, but well, okay, too late now. So, we have looked then at the project work, so automating Toil, and this is just maybe a silly example, but you can think of all the things you need to do manually, just move away from that, because that improves you, but it also improves the company. You can focus on other things. You can focus on the reliability part of things. Then the operational work. So if we look at the operational work, this is the incident lifecycle. And that is the operational work of the SRE. So it's detecting, how can we see that something is wrong, it's responding, it's remediate, so we have to make sure that there is a quick fix in place so that we can actually go on and stay within the error budget. But after that, we are not done. After that, we need to analyze it. We need to really look at it, what is happening here? And well, I heard this great quote of, in complex system, there is no root cause, because it's always a coincidence of multiple things happening at the same time, which brings your system down. But you need to analyze what happened here. You need to understand so that you can actually solve the bigger picture, solve the bigger problems. And for that analysis, you also need all this information. So I don't know if you have heard about observability-driven development. Anybody familiar with that? But if not, that's very interesting practice, because that is about how do you instrument your applications or your systems with enough data so that you can focus on the unknown unknowns. Because when you know what it can go wrong, you will probably have monitors on that. And that is the simple piece. but you don't know, what you don't know, you cannot measure up front. So then you need to make sure that you have enough data so that you can actually do that afterwards. So that is the observability part. Make sure your systems surface enough data. So you have to analyze that, and then you have to be ready. So you have to do testing, you have to do training sessions, you have to do training disaster recoveries, and you need to make sure that you are ready for the next incident that will happen. So if we go through this, go through the phases. So why do we monitor? So we monitor because we want to know, are my applications and infrastructure doing what I expect them to do? But also, are they doing what others expect them to do? And I think that the outcomes of a monitoring can be three things. So the first thing is alerts. So an alert is something that you need to respond on directly. Something is wrong. People cannot buy products anymore. So we need to jump in and fix. Even if it's during the middle of the night, we need to go in and make sure that can be done again. You already see the risks of alerts, because if you have too many alerts, nobody will respond. We will come back to that later. Then we have tickets. That's also a monitoring output. So we monitor a lot, and we see things like, for example, at 4 o'clock every day, we see an 80% boost in our CPU, and we have some scaling issues there. Okay, everything still runs, so there is no panic, but we need to actually solve that. So then we can file a ticket. So we can put a ticket in the ticket system, and we then move it to the backlog or whatever tool you use to manage your incidents. Something that you will look at on longer term. And then third, we need to focus on logging. And logging is something that you typically never look at. Because if everything goes well, the logging is just something, it's there. You don't need it. You start needing it when something is wrong and you end up in the analyze phase. Then you probably want some log files to actually see what happened, to start analyzing and understanding what is actually happening there. So monitoring is all about the detection. We need to know what happens. Then we go to the respond phase. And in the respond phase, the most important question is who is responsible for the response? Well, if we focus on an SRE capability within the organization, it's not only the SRE that responds. So the organization that I'm currently working at, they have many product teams, and those product teams are not well equipped to run 24/7 services. They don't have the people for that. They don't have the skills for that. So they offboarded a lot of things to operations teams, so the traditional developer and operations. Downside of that is that the operations teams, they don't know the application. So if something is wrong, they still need to interact, or they have to postpone a lot of things so that the developers can look at it. When you do an SRE, it's a shared responsibility. So the SRE is just as responsible for the applications and the infrastructure as the development teams. And what you there usually see is that the SRE brings in their knowledge in the team. Also during the day, they will educate the people. And then when you have the rotation schedule for on-call duty, it's not only the SRE team that is on call. Maybe they are 80% of the time on call, but also the people from the product team need to rotate in that schedule. Only because of limited availability and other priorities, they can maybe do it less than the SRE people, but they are not off the hook. It's still their application, and they still need to participate in that on-call schedule. That's also a very good incentive, because if you call a developer out of bed at 3 o'clock in the morning because of some silly bug, and you do it twice, they will probably solve the bug. If someone else constantly solves their issues for them, they don't have a big incentive to actually solve it because they focus on other things. So it brings a lot of cultural transformation benefits with that as well. So one of the things with responding is, of course, alert fatigue. If you put an alert on every single threshold or every single SLO, you probably will end up in a situation that you will just put all your notification systems to silent and you won't look at them anymore. If I receive an alert in the middle of the night that says the CPU just raised to 85%, yeah, is it still running? Yes, it's still running. Then I probably will ignore that alert for good and will never look at it back. So when you are creating alerts and thinking about alerts, you really need to focus on that those alerts are actionable. So alerts are not about logging or notifications that someone has logged into your system successfully, or heartbeats, or normal behavior. That's just normal. You don't want to know that in an alerting fashion. An actionable alert is something that needs a human to investigate. If you have a web server and you can have an autoscaler that scales the web server when it hits a certain threshold, you don't need a human, so you don't need to be alerted on that. The systems will do their work most of the time. So actionable alert needs a human to investigate. And then you need to know some details. Where are the alerts coming from which system, what expectation was violated, why is this an issue for the customer? So if the CPU, the technical stuff is usually not very important for the customer. If a customer cannot buy products and add them to the cart, regardless of the underlying problems of databases, network connectivity, or whatever, that is an important event. That is something that you need to alert on because that impacts the business. And then if you already know what to do in case of a certain type of event, you can already provide some information or even some steps to resolve that. And yeah, well, this is what I just said. It is about the user. So let me quickly show you what you can do in Azure when we talk about actionable alerts. So in this case, I first will start with log analytics again. And I just showed you a query on the request side of things, so that is really a technical thing, the number of HTTP requests. But what I've also done is I've created custom events. So in my web application, every time that I add my product to the cart, I'm logging in the custom event into Application Insights that says add to cart. And now it's very simple, but you can, of course, instrument that with a lot of extra details as well. So every time adding, that is a add to cart event. So when I look at my, I just pick this one here. Look at my custom events from, no, not 30 days ago, but let's say 2 days ago. I can have these kinds of graphs as well. So I say, okay, all my add to cart events, count them. All my remove to cart events, count them. And then I have the same mechanism as my SLOs. I have an expected sales of, for example, 20 products an hour, or 20 products a day, or whatever you think is useful. And then you can project that. So this is the unknown unknowns. I think, based on trends or based on all kinds of intelligence that I have, I know that I will sell 20 products a day. So when it drops below those 20 products, something is maybe wrong. Something out of the normal is wrong, and I don't know what. There is a human needed to actually investigate that. And maybe it's fine, but it is a signal that you might want to take a look at. So then you can, if you say, okay, well, I want to have an alert on this one, you can press New Alert Rule. So if you do that, you will come into this screen where I already set this up, because you need to do some tiny modifications. So this is that query here. But the only thing that you need to add is you need to add a column called aggregated value. This is how the alerting mechanism works. So add a column aggregated value that is now talking about the sales. And then I can have an alert on a metric measurement that says, for example, when it drops below the threshold of 10 or 20, and that happens, then raise me an alert. When that's done, you can go to an action group. And an action group is something that you can also define. And it's not only people. You can do all kinds of things in here. So I can send an email or a SMS or text message to people. So that's probably what you want. Email is not really something that I will look at in the middle of the night. So maybe you want to send a telephone call or an SMS. But you can also do already some automation. So in this case, I created a webhook action for creating an incident channel. Because what I like to do is that when there is a problem and we need to start investigating, we need to bring in people, and then it's nice to have some kind of an incident bridge that everybody is on and has the same shared view of the information that is at hand. So that is a very, very good practice. So in this case, I have created a webhook. And in my example, this webhook is a logic app. And this logic app is very simple again, but it does the trick. When an HTTP request is received with some JSON payload, it creates an incident channel in my Slack and posts a message with information that I already have at hand. So when I run this hook, and because of the timing, I cannot really lower the threshold because it takes some of the minutes to actually have log analytics analyze the information. But when I send the payload, this payload to my webhook, it actually creates me a Slack channel with all this information already in. So that's a very nice way to let the automation work for you. Instead of gathering it from log analytics here and log analytics there, you can actually push that in. And as an extra, what is really nice is that if you look at, and that was for me, it was a hidden feature, in application insights, there is troubleshooting guides. And troubleshooting guides are, well, gathered metrics, it's markdown, so you can add some text, you can add all kinds of data. So this is, well, guidance for someone to say, okay, well, this happens, you can start with this troubleshooting guide, you can walk through the steps, that helps you in finding the right things. So these troubleshooting guides can also be shared with a link, so maybe you should add the troubleshooting guide link to your Slack channel as well, and then you can have a nice starting point. Everybody is on the same page then. Right. So when we then move to the remediate, is that remediate is about MTTR when we do DevOps and all that stuff. So the mean time to repair. We should have that as low as possible. And that is something that we can constantly improve on. So how long does it take to have my service back to normal again when an incident happens? So, and if it requires some code change, how long does it take for the bug to be filed until it's running up and running in production again? So that time, well, that should be as short as possible. That's what we call mean time to repair or mean time to recovery. And that is a metric that we can really use in the remediation phase. And that's where also continuous delivery comes in. Because continuous delivery, that was always projected as, this is the new way, and we can push out business features as fast as possible, and we have to be better, faster, cheaper, and all the business talk. Continuous delivery is now the means to an end. Because if you have to do a manual deployment and it takes you maybe 3 or 4 hours to redeploy your application to actually fix a bug, that's not really nice. But if you have automation in place, if you have continuous delivery, so every single deployment that you do runs through that same pipeline, then you can just do a code fix and safely run through your same pipeline as you do as always. Run your tests and deploy your fix. So that's why we also have a shared toolbox, the SREs and the product teams that focus on the same code base and also the same tools to actually deploy that code base. So when then your incident is solved, you can go to your analyze phase. And that phase is usually skipped in companies that I work for because there is no time. But this is one of the most crucial phases because this is your learning. This is what went wrong and what can we improve so that it doesn't happen another time. And one of the very good mechanisms to do that is a blameless learning review. So a blameless learning review is, the point here is blameless. So instead of sitting in a room and pointing at each other like, yeah, because you rebooted the server, this happened, and then that's when she came in and did that, or whatever, you just walk through the process factually. Involve everybody that had a part in this incident, do it as fast as possible after the incident, and focus on what happened. So what did you know at the time? Why did it make sense to act in this way? What information did you have to actually make this decision? Instead of asking, why did you do that? But focus on the facts. This was the information, that's why you made this decision. Okay, fine. So next time we should maybe instrument our application a little bit better to have more information at hand and make better decisions. And a good way is to create a timeline. So the incident happened, and then this happened, and then this happened, and then he came in and he did this action, and then she came in and she did that action, and that's a real true timeline. So outcome of these blameless reviews are countermeasures. What are we going to do to actually fix this? And we are going to put that on the backlog of the teams for the longer term and for the shorter term. And also important, you need to write a summary of it. So don't keep it for yourself or within the product team. Share it with the organization. And like Microsoft does for a lot of the bigger services, they share it with the outside world as well. They really give it very detailed step-by-step on, this is the incident, this is what we knew, this is why we handled like this and this and this. So an internal and an external summary is also part of the learning, because you will receive feedback from other people to maybe improve your process or to get some extra information. I already showed you the troubleshooting guides. So mistakes are meant for learning and not for repeating. It's something that we really need to make sure. So that's the readiness phase. Something went wrong, fine, we dealt with it, okay, but we don't want to deal with that same mistake again. So once we have countermeasured it, wrote a report out of it, shared our learnings and experience, we need to make sure that it will be ingrained in the system. So we can train for that. So if you look at firefighters, they spend 80% of their time doing training and only 20% of the time in the real work, luckily for them. And we, as engineers, should do the same thing. One of the things that is very useful is the pole attack, which means something like, you just take the most important person. Everybody knows that person that is in your organization and does everything and knows all the systems and has all the access credentials. That person, just do a training and set him aside. Send him home. Because he won't or she won't not be part of that process, and we will surface all kinds of information that we probably don't have at hand. It's not documented, it's in someone's head. So the pole attack is a very useful thing. Use training days, game days, on-call rotations. Make sure your escalation paths are in order. Make sure that you have communication channels, so like Slack, for example, have a dedicated channel for every incident. And don't be shy of chaos testing in production, because that's where the real stuff happens. And if you take in mind that error budget that you have that room to actually experiment, because we only need to have that threshold. The error budget can be used to learn, as long as we stay within the budget. So, that was a lot of information. So to wrap up, what we started with, the SLA, the 99.9%, consider it very carefully. Is it really, really needed to have such a high SLA, or can it be lower? Because the lower it is, the more error budget we have, the more flexible we can be in our deployments and our feature releases, and the more we can learn and improve. When we have 100%, we cannot improve anything. We can only be worse. Site reliability engineering, the practice, or a site reliability engineer, the person, is not a new ops guy that you can throw stuff at. That is if that was the message that you take away, that would be the wrong one. It is something that is a shared responsibility with the product teams, and they have only a different perspective on the same product. Take a look at service level objectives and error budget, because they give a very nice contract to keep everybody on the same page when it comes to what is expected from us and what is expected from the product, and it gives you the flexibility you need. Measure everything so that you can also analyze the unknown unknowns. And don't forget, close your loops with learning, the blameless learning reviews. That was it. My name is René. I work at Xspirit, one of the organizers and founders of Global DevOps Bootcamp, which is my shirt here. I am around for the rest of the conference. If you have any questions, don't be shy. Thank you for your attention.